Good. What's good? I am definitely trying to change my intro, so bear with me. In this video, we are looking at how to use the crosshatch command in AutoCAD. It's fairly straightforward, and my intention is to walk you through the steps, and I hope you'll be able to use it in the future. So what we're doing first of all is I just drew a rectangle using the quadrilateral command or the rectangle command, and I'm dividing it into 4 equal parts. Right, next we are going to enter the hatch command. I'm just going to type it in, and you can see that the commands have changed at the top there to reflect what we're about to do. We are going to do some hatching. Right, the first thing I did was change the layer. I wanted some white lines, so I changed that, and then I changed the pattern. So I'm clicking now in a square, and you can see that it just turned to a white rectangle. We really cannot distinguish between the lines or anything like that. So I'm going to do some editing. So in this bar, I am changing the spacing between the lines. It was on 1. I entered 10, I typed 10, pressed enter, and this is what we have, but it's still not wide enough. So I entered 50, pressed enter, and you can see the end result here. The lines are much wider. Let's do some more hatching. So I'm going to change the pattern to these double lines. Again, the spacing is set to 1, and I want to increase it. So this is 50, and you can see that the spacing has changed. It might be a bit wide for the space that we are using, so I'm gonna go back to 30, and this is what it looks like with a 30 spacing. Let's go to the third quadrant, and we're gonna change now the angle. So the angle is set to 0, which is the default. I'm gonna change it to 45 degrees, and you can see that the lines are now vertical in our last 2 quadrants. Right, so when you change the angle, it literally changes the angle of the hatch. So we're in the 4th quadrant now, and I'm going to change the angle once more to 90 degrees. Alright, so you can see now that it's the opposite direction of our first quadrant. And yeah, that's it for the most part. That's the changing the spacing, getting the direction or the angle, and you have to ensure that when you are doing crosshatch, that the space you are crosshatching in is enclosed. Okay, so what we're going to do today is we're going to look at different ways to divide a line into equal parts. Firstly, we're going to use the AutoCAD command, and it's very simple. You go to the draw command, and then you go to divide, as you can see me doing here. So you select divide, you click on the line, and then they ask you, well, how many pieces do you want to divide the line into? Naturally, I said 10. Right, there we go. So what happens is you cannot see it now, but instantly the line has been divided into 10 equal parts. Now to show you these parts, I'm going to draw a line at each division point, and they actually show you where the points of division are, so you can see them. Alright, so we have our line here. It kind of looks like a brush that is lying on a table, something like that, a comb maybe. If you count the spaces in between, you will see that we have 10 spaces. Now, to ensure that everything is what I say it is, I'm gonna actually go through the process of numbering them. So I'm just speeding this part up a bit. You can see me numbering the spaces, and there we go. We have 10 spaces, right? So that's how you use the AutoCAD command. You use the divide command, and you select the line you want to divide. You enter the number of parts that you want to divide it into, and that's it. Have our layer here, and then you can go through and change the line weight. The line weight is really the thickness of the line. I'll just put it on 0.20 millimeters. Okay, and that's it. We have just created a new layer. So what does our layer look like? Let's draw a line. We are still in the construction line layer, so I'm gonna come here and select color blind. Remember, we called it color blind, so I'm going to select color blind, and now I am drawing the line. If we zoom in, as I've done here, you can see the line, right? It's a straight line with a square, straight line, square. It's called fence line. What is it called? What is this called? Yeah, it's called fence line. I was correct. Okay, good. But one thing is missing. This line, currently we are not seeing how thick the line is. We are not seeing the line weight. And that is because this icon here is turned off. This line weight display actually shows you your line weight. So if you take it off, everything will have the same line weight. If you turn it on, as I'm about to do now, all of a sudden everything will carry their true line weight. Now I'm not seeing much of a difference in our newly drawn line, so let me just change the line weight a bit. I want to put it to something ridiculous. Okay, now we can definitely see the difference in it. It's a thicker line now. See? It's a thicker line because we have changed the line weight and we have line weight display on. Again, I'm going to take it off so you can see the difference. So that's it off, and this is it on. So that's it. That's how you create a layer. That's how I created all of these layers. And if you do not know what a layer is used for, stick around. Please subscribe, leave a like, and in a future video I will explain what we use layers for and why they are so important. Hey everyone, thanks for tuning in. We have a very short video today. Basically, I'm going to be showing you exactly how to select items in AutoCAD using the mouse. Alright, in a lot of videos, persons see me selecting items usually with a box, a blue or a green box, but you may not understand exactly how I get it done. So this video is an explainer. Thanks for watching. Okay, so we're gonna use an ellipse that I've drawn before as our example. I'm dragging from left to right. I'm keeping my finger pressed on the left mouse button, and you can see that the highlighted area is blue. Now I'm going to drag from right to left, keeping my finger on the button, and you'll see that the highlighted area is now green. Now there's a reason for this, and I will explain it as we go along. Now this is what it looks like when you leave your finger on the button, on the left click mouse button. Now in the left to right drag, it only selects lines that are totally covered. The left to right drag only selects lines that are totally covered. Whereas in the right to left drag, or the green drag, once any part of a line is covered, the entire line is selected. So the blue, or left to right, the entire line must be covered. The green, or right to left, the only part of the line needs to be covered. What I'm doing now is I just clicked the left mouse button, I let it go, and then I dragged the mouse. So that's how you get this square, and you can see that I covered basically everything. This is left to right. So I did it again, but you realize that only some of the lines are highlighted because I covered the entire line. That's how the blue highlight works. Now I'm going to do it with the green highlight, and you can see that although I only touched certain parts of lines, there are way more lines highlighted, and that's because that is how the green highlight works. Alright, so blue highlight or left to right, you have to cover the entire line, and green highlight or right to left, you only need to cover a part of the line in order for it to be selected. See. Hey everyone, welcome back, and this is a very short video. We're just gonna take a look at AutoCAD 2022, specifically the trim command. So I did a previous video about the trim command, my favorite command, and I noticed while using AutoCAD 2022, I noticed that the command has been updated, right? How it operates. So basically, as you can see here, I did a grid, and what you do is you just enter the command and you literally just click whatever you want to cut out. So what the software does is it automatically identifies, okay, this is a cutting point, that's a cutting point. So you can see me cutting between lines, you can see me cutting additional lines, anywhere. And that's how it works. So it's easier, it's simpler, and I absolutely love it. Alright, so today we're gonna learn how to make polygons using the command in AutoCAD. And after this video, the next video I upload will actually show you how to construct polygons using AutoCAD. Alright, so we enter the polygon command, and the first thing that they ask us is how many sides do you want. I started with 4. This is a square, as you can see, and they also ask you if you want the shape to circumscribe a circle or if you want it to be inscribed in a circle, right? And then you enter the radius of the circle that you want to use. So you're gonna do 3 or 4 different polygons. Our first shape is arguably not a polygon, it's a quadrilateral, it's a square, but I just wanted to show you that you can do it for a square also. And then we are going to move on to the polygons. What I'm doing here is I'm just offsetting this line so it will serve as the center point for all our future polygons. Okay, so let's go. So I'm entering the polygon command. I'm going to change the number of sides to 5. Right, you specify the center and then you say, okay, I want it to be inscribed in a circle, and you enter the radius. It's that simple. So by me saying I want it to be inscribed in a circle, it means that a circle of radius 100 millimeters, its circumference will pass through all the external points of my polygon. Right, so this new polygon, this is a hexagon, 6 sides, and the last one I'm gonna do is an octagon. I'm gonna change the number of sides to 8, and yeah, inscribed. Good. So these are the most common polygons in technical drawing. If you exclude the square, the most common polygons would be the pentagon, which is 5 sides, the hexagon, which is 6, and the octagon, which is 8. Alright, the others are heptagon, which is 7 sides, nonagon, which is 9, decagon, which is 10, and dodecagon, which is 12. So these are our polygons. I'm actually gonna go ahead and label them. And it's just that simple. AutoCAD makes it really, really easy to create a polygon. All you need to do is just tell them how many sides you need, and just tell them if you want the polygon to be inscribed in a circle or if you want the polygon to circumscribe the circle. When I draw a circle of radius 100 around my square, the circle actually circumscribes the square. Likewise with the pentagon, the radius is also 100. And now I'm gonna copy this circle and paste it over my hexagon and my octagon, and you'll see that it's the same size circle for each polygon. So when you are doing your polygon and they ask you if you want it to be inscribed, they're actually asking you if you want the polygon to be inscribed in a circle and not if you want the circle to be inscribed in the polygon, right? So I just need to clarify that. So we're gonna move on now, and we're gonna draw some circles in our second row of polygons. Now, as you would have seen, I copied these polygons so they are the same size as the ones above. And in the case of the ones above, all the circles are the same. The radius of the circles are 100. Now let's see what happens when we put the circle inside the polygon. So in this case, our polygon will be going around the circle. Now, before we reveal the radius of our circles, do you think the circles in the bottom row are all the same size? Like, just look at them. Do they look like the same size? So actually they are not. So the radius of this circle is 80.94. The radius of the circle for the hexagon was 90 point something. Let's put a circle inside our octagon now. So this is 92.39, and let's check the radius of the circle in the square. It's 70.71. So it's obvious that the bigger the polygon, the bigger the circle inside. Okay, so after recording the video, it occurred to me that I did not demonstrate the polygons with the circumscribe option. So I'm just gonna do that now. I'm not gonna do the square this time, starting with the pentagon. So in the earlier in the video, you would have seen me select the inscribe option, and I explained all of that. They're actually not inscribing the circle, but the polygon is going inside of the circle. So now what we're gonna do is we're gonna keep the radius of the circle the same. Each circle is gonna have a radius of 100 millimeters, but we're actually gonna put the polygon around the circle. So when we select circumscribe around circle here, that's exactly what it means, right? So our first shape was a pentagon, 5 sides, and then who could remember how many sides the hexagon has? Yep, hexagon has 6. Then I did a heptagon, that's with 7 sides, so that's a new shape, and our final shape will be the octagon, right? But the circle for each will have a radius of 100 millimeters. What I'm doing now is I'm just gonna copy the polygons that I just drew and paste them, put it over the previous one so that you can see the size difference. Right, so when the polygon is circumscribed about the circle of radius 100 millimeters, as you can see, we wind up with it's not far greater or much larger in size, but the less, my words are beating me. The pentagon, which has 5 sides, you can see a greater difference. And then the hexagon, which has 6, you see a difference, but it's less than the pentagon. And then the octagon, which has 8 sides, the difference is even less, right? So just some interesting things for us to note. And as you can see, the circles in all of these polygons have a radius of 100 millimeters. It's the same circle. And yeah, these are just little differences and little tidbits that I think we should know, right? So it's the difference between having the polygon circumscribe the circle or having the polygon be inscribed in the circle. So stay with me, it's not a long one at all. So we're going to use one of our ellipses from a previous drawing, and I'm just going to demonstrate the use of the command. So I select the ellipse, I right click, I go down to scale, and they ask me to select or to specify my base point. I click anywhere, and then I enter how I want it to scale. So in this case, I entered 2 and pressed enter. So what would have happened is immediately my ellipse would have turned to twice the size, right? That's what happens. I'm gonna do it again. I select it, I'm gonna specify my base point once more, and this time I enter a scale of 0.5. And if we know our math, 0.5 means half. Once I pressed enter, you would have noticed that the ellipse immediately turned to half the size as it was originally. And I'm just using 2 and 0.5 here, but it can be any number. You can scale something to 10, you can scale it to 100, you can reduce it to 0.1 of the original size. It doesn't matter. What I'm gonna do now is I'm gonna show you that it actually works. I'm gonna check the dimension of the small axis of this ellipse, and you can see it says 2100. That's millimeters, or the minor axis, it's also called. What I'm gonna do now is I'm gonna select it, right click, scale. I'm gonna specify a base point. In this instance, I chose the center of the ellipse and I entered 0.5, right? So that's the scale that I went with. Now I'm gonna check the minor axis again to see what it is. And true to form, it says 1050, which is exactly half of 2100. Right, so I just showed the dimensions so that we can see that it literally became half. It's the same ratio, right? So you know that everything else was halved also. And that's it. That's the scale command. Feel free to use it anytime you need it. If you learned anything, please leave a like or subscribe if you haven't already. Today we are going to learn how to prepare your drawing for printing in the paper space, how to set the scale, and how to save as a PDF so you can print anywhere or open on any device. Okay, so we're going to begin with these 2 drawings. We would have done these in a previous video, and so let's say you have these drawings and you would like to print them on a piece of paper. What you do is you go down to these layout tabs below here. I'm going to click on layout 4, And what you see basically is a blank sheet of paper. Now this is not the size of paper that we want. So you right click, select Page Setup Manager, click on Modify, and in here you can change the size of your paper. So I selected tabloid. As you can see, it's 11 by 17. Everything else stays the same. Everything else stays the same. You click OK, you close, and you can tell that the page just got a bit bigger, right? Now you're not seeing any drawings here, and that's because we do not have a viewport open. So let's do that. Let's click on the Layout tab, and you can see here the different types of viewports that you can have, but we are going to go for a rectangular viewport. So you click one corner and you drag it all the way across, and voila, there you have it. The drawings have appeared. So the viewport is basically a window, and you're looking at the drawings that you have done in your model space. I'm going to change the viewport border from yellow to black so that it's more visible. Okay, this is much better. Now below there you can see it says model or paper space. Right now it's in paper or paper space, and if you just scroll on the wheel on your mouse, you'll see that the paper gets bigger and smaller, right? But the drawings themselves don't change in size. If you click on it and it changes to model and you scroll, now you see that your drawings have become enlarged. The size of the paper hasn't changed, but the drawings got bigger, and you can even draw in this space. Once it's in the model space, you can draw just like you normally would. There's no difference here. See, if I switch back to our regular view, you still see the lines there. So some persons actually draw in this space and not in the general open world of the model space that we usually use. So we have our drawings, and I'm scrolling my mouse, and the drawings, we are zooming in and out, things that we are all familiar with, right? If I go back to paper and I scroll the wheel, the entire paper gets bigger and smaller, as you can see. So I'm toggling it back and forth between paper and model. So we want to set the scale, and these numbers here are representative of the scale. Right? If you click on it, you'll see some preset scales. So let's try some. Let's see which one works. 1 to 5 does not fit. 1 to 8 is still too large. 1 to 10 is still too large. 1 to 16 seems like the perfect size. 1 to 16, everything fits within the borders of the paper, and it's great. So once I get this, I switch it back to paper space, so that when I scroll, if I scroll the wheel on my mouse, the scale doesn't change. But if I leave it in the model space and I scroll the wheel, then the scale will change, because I will zoom in and out of the drawing. So when you're doing the template for your drawing, down at the bottom, you would say what scale it is. So in this case, it's 1 to 16. In a future video, I will cover the template, how to set up your template. Alright, so there we have it. It's still 1 to 16. Now you can add new scales if you desire. You can go to custom, click on add, then you can enter the scale that you want. Well, the name of the scale. So in this case, I'm typing 10 to 1, and that's a name, and the actual paper units will be 10 to 1. Then you click OK, and that scale will be there, and you can use it, right? I'm canceling because I do not want that scale, but you can do it if you so desire. Now, we have our drawings, we have our scale, and so on. Now we want to print. We want to save as a PDF. Now I just pressed Control P, and Control P is the shortcut for print in Windows, right? And here you can see that, yes, this is the print related stuff, but some of us may not want to use a shortcut. So you click on the big red A in the top left hand corner, you come down to print, you go to plot, and when you click on plot, you'll see that the same window opens, right? So it's just faster to press Control and P. Now I want to print mine, or I want to save it as an all black drawing, so I'm going to select monochrome. Under the plot style, I'm going to select monochrome, and over here is where you would normally select your printer. Now I do not have a printer connected and I want to save it as a PDF, so I select Microsoft Print to PDF. Right, everything else stays the same. You click preview, and voila, what you see here is they're basically showing you a preview of what you would get if you were to print this right here and now. And it's very good to use the preview feature, because sometimes you get some nasty surprises. Okay, so let's save it as a PDF. I click OK, and you select where you want it to go, the folder or whatever. You can put the name. Right, of course, I'm writing a nonsensical name. Your device will save it as a PDF, and this is saved. It's right now, it's like any other PDF that you encounter. Right, we are actually going to go to the folder that we have it saved in. But before we do that, yeah, I was just going over some stuff, how to access it. Anyway, so this is the folder that we saved it in. Select the drawing, open. It will open in a browser or wherever you view your PDFs. And let me just reduce the size a bit so that everything will fit in the frame. And here you have it. This is a PDF. You can email this, you can save it on your device, you can open it on your phone, you can send it to a PC that runs, a PC from 2000, whatever. It's a PDF just like all other PDFs. It's not saved as a DWG file, that's a drawing file. Right? I hope you learned something in this video. Thanks for watching. Please like and subscribe.